Hey, welcome back to the IT office. Did you know that using a single switch, you have the capability to have multiple isolated networks? Well, in this video, I'm going to explain you about VLANs, what VLANs are, what VLANs do, what is VLAN tagging, and so on. So let's see this topology we have here. We have a couple of switches, we have 5 devices, and we have these devices in this green box that are labeled VLAN 20, and we have also these 3 devices here in this VLAN 10 inside this green box here. So what is a VLAN? Let's go back in time and let's think about you having a switch, right? Let's see this switch here, and this switch was the only switch you have in your network, right? And you have all your devices connected to this single switch. So from the past video, we talked about the MAC address table and how all the devices in a switch connected to a switch are in the same broadcast domain, okay? So all these devices connected to this switch, they are in the same broadcast domain by default, so they share the broadcast traffic. So if I send a packet from this device that is broadcast, it will be received by all the other devices in the network. If you see the MAC address table of the switch, for example, you see here this column, VLAN, you see the MAC address, type, and ports. So you see this column that says VLAN. This is VLAN 1. Okay, what is a VLAN? Basically, a broadcast domain. Okay. So at some point in time, we have the requirement to divide networks because of security concerns or requirements. So instead of having, for example, one switch for some specific set of devices and then another switch for another set of devices, the industry came out with this concept called VLANs. So what does it mean? Instead of having multiple switches for different group of devices with different networks, we can use a single switch and share the switch having different broadcast domain. That is like virtualizing the switch. So what does it mean? Let's say we need to create a network for these 2 devices and another network for these 2 devices and keep these other devices in this network, okay? Just use the color and bear with me in this explanation, okay? So we have a single switch, right? But we need to create different isolated networks. Let's say a network for cameras. We also need a network for, let's say, finance users, and maybe we need another network for all the other users, okay? So instead of purchasing 3 different switches to have these 3 different subnets, we can use the VLAN concept and split this switch in 3 different broadcast domains. So for example, in the topology we have here on the left, I will create VLAN 20, and I will include Windows 4 and Windows 2 in that VLAN, and I will create VLAN 10 and will include Windows 3, Windows 1, and Kali Linux 1 in that VLAN. So this will be 2 different broadcast domains. As in this example, we can split the switch in 3 different broadcast domains. That means like having the switch virtualized in different broadcast domains, right? Like think about that, about VLAN like a virtual switch, because indeed the name VLAN comes from virtual LAN, okay? If you have a small managed switch in your home, it probably doesn't support VLAN like all switches do or a managed switch do. But enterprise switches support these multiple VLANs. What we do to configure VLAN is we create the VLAN, that's the first step, then we assign the ports to the VLAN, that's the second step, and then we will see that the devices will have in the MAC address table different VLANs ID depending of how we assign the ports, okay? So one VLAN is one broadcast domain, another VLAN is another broadcast domain, and so on and so forth. So they cannot communicate between each other in the same broadcast domain. So for example, Windows 4 will not be able to ping Windows 3 directly if we assign them to different VLAN, okay? So they won't have connectivity at the layer 2 level. Now, what we require for them to communicate? Well, in this case, I need a layer 3 device that helps me route the traffic. Remember, switch, do switching, like forwarding traffic based on the MAC address inside the same broadcast domain. Now think about the VLANs. Each VLAN will have its own switch MAC address table. We are going to see that in a few minutes. And we will be able to send traffic inside the same VLAN. For example, this device will communicate with this device, this with this, and with this one, and between these two devices, okay? But for devices in different VLANs, we won't have communication. We are going to see in the next video how to use something called inter-VLAN routing. We can use a router, we can use a layer 3 switch, or we can use a firewall to route traffic between different VLANs, because by default, different devices in different broadcast domain can communicate at the layer 2 level. Now let's see the switch. Let's start with the configuration and let's configure the VLANs on these devices. So now we have switch 1 and switch 2. So switch 1, we're going to create the same VLAN set on each switch. I'm going to show you step by step, and we are going to discuss additional concepts, okay? So if I run, for example, well, you see all these devices are in the same MAC address table. I number the devices according to, for example, Windows 1 will be this device ending in 1s, Windows 2, then Windows 3, Windows 4, and this is the Kali device, so we can easily identify the MAC address table. So now if we check this other switch, we see everything in VLAN 1. So far, so good, okay? We can use this command, show interface status, also to check the ports and the VLAN assignment, or we can use the show VLAN command. Okay, show VLAN command will show you, for example, will show you the VLANs. Now by default, everything is in VLAN 1. If we don't do any changes, we only have one broadcast domain, okay? So we're going to create the VLANs on both switches and then assign the ports. So to do it faster, I'm going to send all these commands to both terminals at the same time. So let's say VLAN 10, we're going to name it blue. The name is whatever you want, but the ID needs to be the same. I'm going to explain you more about the VLAN ID because this is important, okay? So name will be green for VLAN 20, okay? And now we can run the command show VLAN. Now you will see on each device the VLAN ID and the VLAN will be active, but they don't have any ports assigned yet, okay? So let's discuss a little bit about the VLAN ID. Now we need to understand something called VLAN tagging, okay? VLAN tagging means that, for example, we have something called the VLAN ID, and the VLAN ID represents the VLAN, right? This is 12 bits in length. This VLAN ID is going to be inserted in the frame, but in some specific scenarios. Okay, so by default, we don't use tagging to, let's say, end devices like computers or printers or cameras and so on and so forth. We only assign or associate the VLAN with the port. For example, we're going to associate gigabit 03 here and 02 to VLAN 10, but we won't be doing any tagging. That means that the switch will have a switch MAC address table with anything learned on gigabit 02 and 03 associated with VLAN 10. So now when we use tagging, when we insert that VLAN ID, well, that is going to be done when we send traffic across VLAN aware devices. For example, switch, okay? So in this port, we need to do tagging. Why? Because, for example, we need to send traffic from Windows 1 to Windows 3 through the connection of the two switches. So this switch is going to have two MAC address tables, one in VLAN 20 and one in VLAN 10, and same for this switch. We have VLAN 20 MAC address table and VLAN 10. Okay, so when the traffic comes from, let's say, Windows 1 to Windows 3, we need to insert a tag here for the VLAN ID, which is 10, and then we have the rest of the frame and the data and so on and so forth. So when the traffic reaches the switch, it will check the tag, it will then check the destination MAC address, and it will remove the tag and send it out of this port. Okay, so let's recap. VLAN tagged is used when we need to send traffic to a different device that is also VLAN aware. So here the traffic will be untagged, meaning that this packet won't have any tag, but it will be associated with the VLAN 10 in the MAC address table of the switch. Then when this packet goes to the other switch, we are going to insert the tag with the VLAN 10 in the frame, right? And this switch is going to check the tag, and it's going to select for the portion of the MAC address table of the VLAN 10 what is the destination. It's going to remove the tag and send the packet to the destination device. Okay, so VLAN tagging in Cisco is called trunking. Well, I don't like much that terminology, because trunking for some device, other device vendor means something else, but let's say the standard terminology is VLAN tagging. Okay, so what happens in VLAN tagging when we insert the VLAN ID? So we're going to see the tag in the packet capture, but keep in mind that VLAN ID is 12 bits, meaning that we have 4096 possible value. For example, most switches support from 1 to 4094, or even less in smaller switches, but keep that in mind, okay? So now we need to associate the ports with the VLANs, okay? So we now have the VLANs created, we need to associate the ports. So in switch 1, we need to associate interface gigabit 02. So for Cisco switches, the untagged mode is called access. So it means that this port is going to be associated with a VLAN in the MAC address table of the switch, but it's expecting no tag, okay? So it's going to be associated with VLAN, that's 10, and VLAN 10, and then we have gigabit 03, that is the port connecting to Windows 2, associated with VLAN 20, switch port mode access, switch port access VLAN 20, okay? Okay, now let's do the same for switch 2. We need to associate, I'm going to use the range command here, range, to select multiple ports, gigabit 02 2, 3, switch for mode access. Remember, mode access associate the ports with the VLAN, but you won't expect any tagging from coming from the computers, okay? So keep in mind that when you have your computer, your laptop, you plug into the network, you don't modify anything on the laptop like assigning VLAN tags. That one makes no sense, right? Because it won't be scalable. So that's why we don't use tagging to those sorts of devices, okay? So VLAN mode access, and then switch port access, that will be VLAN 10, okay? And then interface gigabit 10, switch port mode access, switch port access VLAN 20, okay? So pretty much we have this configured. Now let me just pull this window here. It will be easier to see this way. So now let's run a show VLAN in the switch 1. Now you see here that we have our default VLAN with all the ports assigned to it. That it's by default. Most switches come with the VLAN 1 and all the ports in VLAN 1. Now we have the VLAN 10 with the port gigabit 02 assigned to it, and then we have VLAN 20 with the port gigabit 03 assigned to it. Pretty much we're good here, okay? And then let's see switch 2. So we have here VLAN 10 assigned ports are 02 and 03. That's correct. And then VLAN 20 port 10, okay? So just to do a quick test, let's do a ping from Windows 1 to Kali 1. If you see in the diagram the IP address, let's ping 10.10.15.200. That's good, okay? Let's try to ping Windows 3. Oh, what is happening here? The traffic is not responding. So this device was able to ping Kali Linux, which is connected to the same switch, but is not able to ping across the switches to Windows 3. They are in the same VLAN, but they are not able to ping between each other. But let's examine first switch to MAC address table. Let's see, if I run it like this, it will show me everything. But now I just want to see the portion for VLAN 10, okay? VLAN 10, I just show MAC address VLAN 10. I see the two MAC address of the other devices. But why I don't see this entry for Windows 3 in VLAN 10? Because we haven't configured the VLAN tagging between the switches, so they are not passing the VLANs to the gigabit 00. Let me show you, for example, that right now. Let me start a capture here and start a capture in the link between the two switches. Okay, so let's see if the ping is running. Let me run it for a few moments. Let's see what's happening in the captures. Let me see the capture. Okay, so let's see. This device is probably ARPing, just to see what is the MAC address associated with Windows 3. If you want to see the video about ARP, it's here in the channel as well. Okay, so far we don't see that here. And let's check here if we have ARP. We don't have ARP in the link between the two switches. That means that this is trying to send traffic of broadcast to all the ports belonging to VLAN 10, but the broadcast is not being sent here. Why? Because we don't have the tagging. Imagine this is a highway and we have one lane to send packet across VLAN 10 and another lane to send packet across VLAN 20. That needs to be set up. Okay, so let's set it up and see what happened next. Okay, so let me go to the interface. It will be, yes, configure terminal interface gigabit 00, sorry. switch port trunk encapsulation.1q. That means that's the protocol that represents the VLAN tagging 802.1.q. This is VLAN tagging. If you check the standards, that's how it's documented. Then we need to switch mode trunk. Now it will allow VLANs to pass through the port. Optionally, you can, let's leave it like that. I'm going to show you. Show interface trunk. Now, through the port gigabit 00, we are going to pass every VLAN we define in the switch. At this moment, we only have VLAN 1 by default, 10 and 20. So that's the traffic that it's allowed. Okay. Now we need to do it on the other end. We did it here on switch gigabit 00 of switch 1. We need to do it on gigabit 00 on switch 2. So same. Interface gigabit 00, switch port trunk encapsulation.1q, switch port mode trunk. Okay. Oh, now see the magic happen. Let me show you that. Now we're ARPing, and now we got the response. Okay, so I'm going to stop the capture. I'm going to clear the screen. I'm going to stop the capture right here. Okay, so now see the magic happening. Okay, let me show you the packets. Let me show you. Let me pull this a little bit here, side by side. Let's see. So we have the ARPs, right? And we have, this is the connection between the two switches. So let's see a resolution that was responded here, maybe this one. So we see the ARP. This is the ARP request, then we see the ARP reply. But take a look at this field here. This is the 802.1q header with the VLAN ID 10. Okay, so remember, when we send traffic from VLAN 1 to the switch, it doesn't have any tagging. If you see here, it doesn't have any tag. If you see the Ethernet frame, it doesn't have any tag, right? The switch will record the source MAC address of Windows 1 in its MAC address table for VLAN 10, and then it will add a tag, a VLAN ID 10, and will send the packet to switch 1. Switch 2 will send the packet to switch 1. This one is going to remove this tag and send the packet without any tag to Windows 03 because it's associated by the VLAN association that we did before when we created the VLAN. Okay, so here you don't see any tag. If you see the column, you don't see any tag, and then you will see when we add the tag into the Ethernet frame. Okay, so check, you have the Ethernet frame, the 802.1q header, right? We have that small header there, and then we have the request. So that is VLAN tagging in action. Let's see if the ping worked. Let's go back to the Windows 1 device. Now ping is working. Okay, if I capture, for example, if you capture from this device, right, from Windows 1, you won't see any tags in the ICMP packets, right? Then if we capture again between the two switches, so there is no tag here. Now if we capture between the two switches, you're going to see the tag. Let me filter by ICMP. Now the tag is added with the ID 10, And now let's capture also here in the connection to Windows 3. In this one, you won't see any tag as expected because the switch will remove it and deliver the packet. Let's see. ICMP, we don't see the ICMP packet, Giga to Windows 3 Ethernet 0. ICMP, let's see. Is this still running? Let me check. Oh, now I see traffic. Okay, you don't see any tag. Go back to our capture. This is between the switches. I'm going to put one on top of the other one so you can see in parallel. Okay, this is something that you need to understand, because in real world scenarios you will see that people sometimes it's sometimes they are confused by this concept. Okay, so let's recap. Traffic, go here, no tag is untagged. Okay, then when we send it here, we add the tag, right? We add the tag VLAN-tagged, and then we send it here. Okay, it will happen for traffic in VLAN 20 as well. Let's try to see if we can ping to 10, that 20, that 15, that 20, this is 22. Yeah, we're going to ping 40, 42. Oh, sorry, I made a mistake here. This should be 22. Sorry about that. Now we did a ping between the switches, right? But using Windows to device. Let me stop this pin that is running. Let's see. We see the pin from VLAN 20 devices. Yeah, you see over here somewhere. Okay, you see, we see traffic from 10, that 20, that 15, that 22 with this VLAN ID 20. Okay, so now if you check the MAC address table of the switches, they will have address show MAC address table. Right, we can see that we have this column 10 for Windows 1, Windows 3, and 20 for Windows 2 and Windows 4. So they won't mix that traffic. Okay, that won't happen on the switch. You can do anything you want in a layer 2 switch, but for example, I won't be able to ping the 22, for example. That won't happen. Okay, because for that we need a layer 3 device, a router, a firewall, or a layer 3 device or layer 3 switch to route the traffic between the networks. Okay, so let's do a quick recap. First, we have switch ports that are configured as trunk, and we have switch ports that are configured as access. Okay, remember, trunk ports will do VLAN tagging. Okay, so for example, gigabit 00 is the port connecting between the switches. They need to be configured with trunking or tagging of both ends. This is remember, this is the standard term, and that means that this will add the VLAN tag 10 or 20 depending of the MAC address table and what is the device generating the traffic. Okay, now access port that are for end devices like the computers, and they are associated to VLAN 10 or VLAN 20. okay, and these devices will have different MAC address table each for each VLAN, okay, but no tagging. That means that the traffic here isn't tagged, right? But they will be associated to MAC address table, okay? Once the packet comes in, this MAC address source will be associated to the MAC address table of VLAN 10, and when these packets come here, it will be associated to VLAN 20, okay? But no tag is expected from the client device. In the case of servers, for example, you can have a server that supports VLAN tagging and virtualization and send traffic from VMs on different VLANs, but that will also be a trunk port, okay? But regular devices like computers, cameras, or any client device in the network, you usually do not configure tagging, okay? Remember, VLANs are used to create a smaller broadcast domain, okay? Instead of having all the devices in your network, you can segment the network by creating a smaller broadcast domain and assign different IP networks and create different security policies for devices in different VLANs, okay? So I hope you have enjoyed this video. In the next video, we're going to talk about inter-VLAN routing, and I will show you how we can make the communication happen between devices on different broadcast domain. Don't forget to subscribe, like the video, share, and see you in the next.